All right, today we are starting section 10.3. We are dealing with a different type of special right triangle. Today they will be 30, 60, 90 triangles. To warm up, we're going to do a little bit of algebra, solve for the variable. On number 1, this asterisk in the middle here, it means we're multiplying. So how do we undo multiplication? Division. We are going to divide both sides by the square root of 3. But last week we talked about we do not want a radical in the denominator. So we're left with x equals 8 over the square root of 3. But what am I going to multiply top and bottom by to get rid of that radical? Good. Radical 3 over radical 3. All right, that leaves me in my numerator with just 8 radical 3. What's in my denominator? 3. So radical 3 times radical 3, that would be the square root of 9. The square root of 9 is just a 3. Questions about number 1? Okay, what does number 2 look like? A squared plus b squared equals c squared. Okay, so we're just finishing this problem. What would the next step be? Before we subtract, what do we have to do? Square 8. What is 8 squared? A squared plus 64 equals 256. Now we're ready to subtract. A squared equals 192. Next step, square root both sides. When I square root 192, is that a perfect square number? No. So we have to break it down. What can 192 break into? I hear 96 and 2. You want to use 8 and 12 instead? Okay. No, that doesn't work. You mean 8 and 12 for 96? 8 and 12 will work for 96. All right, let's keep breaking down the 12. What do we break into? 4 and 3. Let's break down the 8. What would we break that into? 4 and 2. So I'm going to stop there. What do I have pairs of? I have a pair of 4s and a pair of 2s. They're just really far away from each other. And what's alone? The 3. So I would rewrite this as A equals what?
8 radical 3.
Good. 8 radical 3. We multiply a 4 and a 2 together to get 8. The 3 has to stay on the inside of the radical because it was alone.
You have to break them?
Yes, we would have to simplify it. You don't have to break it down this way. There are other ways to break it down. All right, on number 3, again, this looks like a squared plus b squared equals c squared, or some variation of it. So the first thing we need to do is square the square root of 17. If you square a square root, what happens? It's that same number. Those undo each other. So square root of 17 squared is just 17. Next step to solve. Subtract 17. B squared equals. Okay. Next step. Square root both sides. Is 135 a perfect square number? No, it is not. So we need to see if we can break down 135. What could we break 135 into? What can we break it into? 3 and 45. I like that one. What will 45 break into? 9 and 5. 9 breaks into 3 and 3. What do I have a pair of? What's alone? The 5 and the other 3. So I would rewrite this as B equals 3 root 15. Good. If anything else is alone, you multiply them back together. So the 3 and the 5 got multiplied back together to give us 15. All right, our special right triangle today is a 30, 60, 90 triangle. So the 30 and 60, of course, are degrees. And there is a special pattern about the side lengths. Since none of our angles are the same, none of the sides are going to be the same. Okay, so with a 45, 45, 90, 2 of our sides were the same because 2 of our angles were the same. That's not the case here. We labeled the shortest side, which is across from the smallest angle, as X. The middle side, or the side across from the middle angle, 60, is X times the square root of 3. And across from the right angle, or the longest side, is 2X. So we always base this on the shortest side being X, the side across from the 30-degree angle. If it helps, you can label, like that side is definitely the shortest side, and then the side across from the 90 is definitely the longest side. The other one would be the middle side. Okay, so we have to remember X root 3, 2X. That's our pattern that we have to remember this time, instead of the X and the X root 2. All right, so on this, we are asked to find all missing sides, and we are only given one side in each of these. So I would go around it and label them based on the pattern from before. So the side across from the 30, I should label that as short side, or what variable do you want to use? X. Okay, that'll be X. The side across from the 60-degree angle should be labeled X square root 3. And the side across from the 90-degree angle, they labeled it 10. What would we label it based on that other diagram? 2X. So that allows us to set up an equation. 2X equals 10. If 2X equals 10, what is X? 5. So then I can go back down here. X is equal to 5. So that must have a side length of 5. What about the other side? 5 radical 3. So this one would equal 5 radical 3. And then we have all of the sides. So 5 radical 3 and 5 were the two that were missing. That's it. Okay, let's do the same thing on number 2. The side across from the 30, I should label with what? Across from the 30. Across from the 30 is always X. Across from the 60? Nope. X radical 3. And across from the 90 is 2X. So they flipped this triangle around from the other one, but we still follow the same pattern. Across from the 30 is x, across from the 60 is x root 3, across from the 90 is 2x. We're able to use this bottom side to set up an equation. In this case, what is x going to have to equal? If we solve this bottom equation we set up for x. 6. If we divide both sides by the square root of 3, we're left with x equals 6. So I go to the side that's just an x. That has to equal 6. Then I plug that in at the top. 2 times 6 would be 2 times 6. 2 times 6 is 12. So the sides that I didn't already know when I started were 12 and 6. All right, across from the 30, based on our diagram in our notes, across from the 30, it should be labeled what? Across from the 30. Across from the 30, who can raise their hand and tell me what to label it? Keon. What? It's labeled 8. Jordan, what should I label it? X equals. Based on the diagram, that side should be labeled X. Who can raise their hand and tell me what the side across from the 60 should be labeled? Brandon. Based on the diagram, X radical 3. Based on the diagram, the side across from the 90 should be labeled what? 2x. Once you have all the sides labeled, then you should go back through and see if you can determine what the sides are. If they give you the shortest side, that's the easiest situation. X is already solved for, so you just have to plug it in. 8 radical 3 cannot be simplified, so we just leave it as 8 radical 3. 2 times 8 can be simplified. It becomes 16. Label all of them before you start trying to figure out what the sides actually are. Do not get ahead of yourself. These are not meant to be that challenging, but it's very easy to confuse yourself or skip a step. So let's try it again on number 4. Based on our diagram, the side across from the 30 should be labeled. Who can raise their hand and tell me? Anaya. X. According to the diagram, the side across from the 60-degree angle should be labeled what, Julian? X radical 3. Since they already labeled it with a number, we can turn that into an equation. According to the diagram in our notes, across from the 90-degree angle, who can raise their hand and tell me what it should be labeled? Mariah.
Whoa.
Never mind. Shelby. 2x.
Oh, you said across.
Now we can go back to the one where we set up an equation and we can figure out what x should equal. X should equal 9. So I can go up to the side that's just a plain old x and fill in a 9. The side that's labeled 2x That becomes 2 times 9, which is equal to 18. So I found my 2 missing sides. All right, number 5. Across from the 30-degree angle, based on our diagram, we should label it with an X. Across from the 60-degree angle, according to our diagram, we should label it across from the 60, X times radical 3. Across from the 90-degree angle, according to our diagram, it should be labeled 2x. Since they already have a number there, we can turn it into an equation. How would we solve that equation for x? How would we solve it? We would divide by 2, x equals 12. So I can go ahead and fill that in on my other side where I just have an x. X is going to equal 12. How would I then rewrite my last side? 12 radical 3. So those were my 2 missing sides. All right, we start the process over again on number 6. Across from the 30, what should I label it? X. Across from the 60, x radical 3. And across from the 90, 2x. So I set that one up as an equation because they already put a number there. Okay, what do I need to do to get x alone? Divide by 2. When you do this, I do not want a decimal. I want simplified fractions. Is 51 over 2 simplified?
Yeah.
51 over 2 does not simplify, so that means x equals 51 over 2. When we go to plug that into x to find our last side, it becomes 51 radical 3 all over 2. So the radical 3 goes in the numerator, the 2 stays in the denominator. Questions about how we wrote those? Or about how we found them? Can I erase number 5 so I have a little room for number 7?
No.
We're done with number 5?
No.
On number 7, the side across from the 30 should get labeled with an X. The side across from the 60 is X radical 3, and the side across from the 90 is 2X. I'm going to rewrite my equation from the side across from 60 above so I have a little room to show what's happening. I need to get X alone. How do I do that? Divide by? Okay, when I divide by radical 3, I end up with 36 over radical 3. Is that okay? No, because I cannot have a radical in the denominator. So I'm going to multiply top and bottom by radical 3. So that gives me 36 radical 3 over 3. What can simplify here? 36 divided by 3 is 12. So we have 12 radical 3. That is equal to what variable? X. That's what we were solving for up here. So this whole thing is equal to X. So X is equal to 12 radical 3. That looks strange because we're used to the radical 3 only being across from the 60 degrees. But across from the 60 degrees was a whole number. So the radical 3 had to come from somewhere else this time. So X is equal to 12 radical 3. In order to find our last side, we plug that in. So we take 2 times 12 radical 3. What does that give me? What is it?
24 radical 6.
Ooh, close.
24 radical,
It's 24 radical something. Was there anything to multiply to inside the radical? No. So it's going to stay a 3. 24 radical 3. It's kind of like multiplying 2x by 2 or 12x by 2. It'd be 24x. It's the same idea. All right, I am going to erase 6 so that we have a little room for 8. Number 8, the side across from the 30-degree angle should be labeled with what based on our diagram? An X. So we can set up an equation on that one. X equals 8 root 3. Across from the 60, we should label it X radical 3. Go back to that diagram every time. Across from the 90, we should label it 2x. This one should be a little bit easier because we already know what x equals. We just have to plug it in. So here we have 8 radical 3 times radical 3. What is the square root of 3 times the square root of 3? 3. Okay, this would be radical 9, which is just a 3, but then we have to multiply it by the 8, and what do we get? 24. So this becomes 24 on that side. For our last side, we're taking 2 times x. Again, x was equal to 8 radical 3. So this is 2 times 8 radical 3. What do we get? 16 radical 3. Cannot be simplified, so we leave it as 16 radical 3.